All right, so now we're going to take a function in vertex form, and we're still going to find our x-intercepts, if we have any, and then our y-intercept from this. So, of course, vertex form, we know our vertex really easily from this. So our vertex we're getting from these values here, so it's going to be a -3 and still 8. I'm going to plot that right away. Okay, so -3, 8 is our vertex. So this is either going to be the highest or lowest point of our parabola. All right, x-intercepts. When we're looking for our x-intercepts, we're looking for when, for this, our y value is 0 on the x-axis. Okay, so we're going to let y equal 0, our function here. So we're going to say 0 equals this -2 x plus 3 squared plus 8. We're going to solve for this. So now I don't have these factors. I can't set individual factors because I have this plus 8 here at the end. So I'm just going to take my order of operations and I'm going to solve this. And as I see in this equation too, I only see x in one place. So my goal is to get x isolated and all alone. So I'm going to go backwards. I'm going to undo any addition or subtraction first. So the first thing I'm going to do is I'm going to subtract the 8 from both sides. So -8 equals -2 x plus 3 squared. Then I'm going to undo any multiplication or division here. So that means I'm going to have to undo this times -2. So now I'm going to get a +4 equals x plus 3 squared. Then I want to undo any exponents, and I have one here. So I'm going to square root both sides of my equation here. And so I get a 2 here and an x plus 3 here, which I don't need those parentheses anymore. Now the only thing is, whenever you square root, you do have to include the positive and negative outcome from this. And so this is really, really important. Now the reason why this occurs is because inside here, this value could be a +2, and I could get that 4 when I square it. It could have been a -2, and when I square it, I get that +4. So it didn't matter if that value inside those parentheses was positive or negative. So that's why we're saying this part inside could be a +2 or a -2. And then my last step is I need to subtract 3 from both sides. And now I'm just going to be doing that from a +2, so I'm going to have a +2 minus 3, and I'm going to have a -2 minus 3. That gives me -1, and it gives me -5. These are my x-intercepts, because this is when my function equals 0. So x is -1, and then my function value is 0, and x is -5 when my function value is 0. So I'm going to plot them here and see how they're on either side of that vertex. All right, so we're going to find one last point here. We're going to find the y-intercept, and it looks like 2 is this traveling. It looks like it's going to be a negative value. My y-intercept for this, x is 0 on the y-axis, so let x equal 0. So in the function, we're going to put 0 in. So we're looking at f of 0 equals -2, and then we'll have 0 plus 3 squared plus 8. So we're just putting that 0 in. So this should be a little bit easier to solve. So -2, 3 squared plus 8, -2 times 9 plus 8, -18 plus 8, which is -10. So when x was 0, y was -10. So I'll plot that. And then we can put that all together. So again, it was in vertex form. I did not have to change it into factored form to find those x-intercepts. I did not have to change it into standard form to find that y-intercept. I could still do them because I'm taking those principles of really for my x-intercepts, I'm setting my function equal to 0. And to find the y-intercepts, I'm setting y, or x equal to 0. Okay, and so just in that factored form, we can see the x-intercepts really quickly, hardly have to do any work. We had to do some more work here. And same thing with the standard form, we can see the y-intercept really quickly, hardly have to do any work, but still possible to find it. So we're going to practice a few more here of really finding those x-intercepts, and I already have these set equal to 0 right away. So it's like the functions equal 0, so we're finding those zeros or the x-intercepts. So again, we're using that order of operations and going backwards. So that PEMDAS, and we're going backwards because we're undoing. I see x in only one place here. So it's a great way to solve equations. So I'm going to subtract 20 from both sides, so I get a negative 20 equals negative 4 x plus 1 squared. I'm going to divide by the negative 4, so now I have a positive 5 equals x plus 1 squared. I'm going to square root. I'm going to show this. And when I square root, I'm going to get a decimal here. So I'm going to use my calculator, and this is going to be an irrational number, means it never repeats, never continues on. So we are going to have to round this. We'll round it 2 decimal places. So 2.24, because this says 36, equals x plus 1. And this could be a positive or negative value for this. So don't forget that plus or minus. And then I want to subtract 1. So I'm going to break this apart. So a positive 2.24 minus 1 and a negative 2.24 minus 1. So I'll get 1.24 and negative 3.24. These are my answers. Now I could plug them back into, I could check by plugging into the function or into the equation. And I'm checking to make sure that they equal 0. It's going to be about 0. It won't be exact because we did round. Let's try this with the next one. So I'm going to subtract 6 from both sides. So negative 6 equals 3x minus 2 squared. I'm going to divide by 3. So negative 2 equals x minus 2 squared. And then I'm going to square root. Now when I square root, it's going to say error. This is a this is an irrational number. Or sorry, this is a non-real number. So here there is no solution. If we were looking at x-intercepts, there would be no x-intercepts. This parabola would be above the x-axis totally or below the x-axis totally. It does not cross it. So in A here, it crossed it just at decimal values. But for B, it won't cross the x-axis at all. So this is a way that we can solve the equations, especially if it's in this format. It's really easy to be able to get x alone, and we want to see x just one place. So if we were to write it in standard form, we'd see x in 2 places.